Somewhere in your body, right now, there's an atom of hydrogen older than the sun, older than the Earth, older than every star you have ever looked up and seen. It has existed, unchanged, for over 13 billion years. It was there before galaxies had names, before planets had shapes, before there was anything solid enough to stand on. And it was made in the first 3 minutes of the universe's existence. No footage of this moment exists. No photograph, no eyewitness, no light. What you're about to see is a reconstruction, built from the closest thing physics has to a black box recorder. The math that lets us run the universe backward, second by second, to the very beginning. This is the story of the 3 minutes that made everything, including you. Let's be honest about something before we go further, because it matters. There is a wall in physics we cannot see past. Go back far enough to roughly 10 million trillionths of a second after the beginning, and our equations simply stop working. Gravity and quantum mechanics, the two most successful theories humans have ever built, contradict each other completely at this scale. Physicists call it the Planck epoch, and honestly, calling it the beginning is a bit of a cheat. It's really the beginning of what we can currently describe. What happened before it, or whether before even means anything at that point, nobody knows. Anyone who tells you they do is selling something. That might sound like a disappointing way to start a documentary about the origin of everything. It's actually the opposite. It means everything from this point forward isn't guesswork. It's been tested, measured, and confirmed by particle accelerators and telescopes. We're about to walk through the only part of the universe's biography that we can actually verify. What we can say with confidence is this: whatever happened before the Planck epoch, by the time our story picks up, the universe was already unimaginably hot, unimaginably dense, and expanding outward in every direction, everywhere, all at once. So let's start the clock. At 1 trillionths of a second, the universe did something it would never do again. It inflated. In a fraction of a second, space itself stretched by a factor of at least 10 to the 26th power. That's a 1 followed by 26 zeros. To put that in perspective, it's the difference between the width of a single atom and the width of an entire galaxy, happening in less time than it takes light to cross a proton. This wasn't an explosion happening inside space. Space itself was the thing expanding. There was no center, no edge, no outward. Every point simply got farther from every other point, everywhere, at once. Cosmologists call this period inflation, and it solves a problem that used to keep them up at night. Why does the universe look almost exactly the same in every direction we point a telescope? Inflation stretched out any early irregularities so violently that the universe was left almost perfectly smooth, with just enough tiny ripples left over to eventually become every galaxy that would ever form. Those ripples are, in a very real sense, the blueprint for everything that comes later in this story. But before any of that blueprint can matter, the universe has to survive something else first. A single, split-second imbalance that decides whether there will be anything left to build a galaxy out of at all. We'll come back to that. For now, the clock keeps running. As the universe expanded, it did the one thing expansion always does. It cooled. And in physics, temperature isn't just hot or cold, it's a measure of how violently particles are colliding. At the temperatures we're talking about here, over a quadrillion degrees, something strange happens. The fundamental forces of nature, which we experience today as 4 completely different things, gravity, electromagnetism, and the strong and weak nuclear forces, behaved as a single, unified force. As the universe cooled past a critical threshold, that unified force broke apart, the way a single note played too lawful will split into overtones. This is also right around this moment when the Higgs field switched on, an invisible field that fills all of space and gives particles their mass. Before this instant, nothing had weight in any meaningful sense. After it, matter as we understand it became possible. Physicists have partially recreated this exact split inside particle accelerators, confirming that electromagnetism and the weak nuclear force really were once a single, unified force, exactly as the equations predicted decades before anyone could test it. You're currently made of particles that only became particles, in the modern sense, in the aftermath of this split. For the next fraction of a second, the universe was not made of atoms, or even protons and neutrons. It was a soup. Physicists actually call it quark-gluon plasma. So hot that the particles which would eventually build protons and neutrons couldn't stick together. They existed free, colliding endlessly, in a state that hasn't naturally existed anywhere in the universe since. Imagine trying to build a brick wall while someone violently shakes the ground underneath it every fraction of a second. The bricks can never stay stacked long enough to form anything. That's what was happening to matter itself, everywhere, all at once. We've actually recreated tiny droplets of this exact state on Earth, briefly, inside the Large Hadron Collider. Which means this isn't speculation. We've watched a piece of the first microsecond of the universe happen again, on purpose, in a tunnel under the border of France and Switzerland. As the universe kept expanding and cooling, the quarks finally slowed down enough to bind together, locking into groups of 3, forming the first protons and neutrons the universe had ever seen. The raw material for atoms had just been built. But there weren't any atoms yet, not even close. Quick reality check before we go further. Everything we've described so far, inflation, the split of the forces, the quark soup, happened in less than 100,000th of a second. We're now arriving at the 1 second mark. In the universe's own timeline, we've barely started, but this next second is the one I promised we'd come back to. Here's the part of this story that should genuinely unsettle you a little. For every particle of matter created in the early universe, the stuff that makes up you, me, planets, and stars, physics says there should have been created an almost identical amount of antimatter, same mass, opposite charge. And when matter and antimatter touch, they don't coexist. They annihilate each other completely, converting entirely into pure energy. If matter and antimatter had been created in perfectly equal amounts, they would have wiped each other out entirely. The universe would be nothing but light, forever. No atoms, no stars, no you. But they weren't created in perfectly equal amounts. For reasons physicists still don't fully understand, one of the biggest open questions in cosmology, for roughly every billion particles of antimatter, there existed 1,000,000,001 particles of matter. Physicists usually measure this using the ratio of matter to leftover photons, rather than counting particles directly. But the imbalance, and everything that follows from it, works out the same either way. When the annihilation finished, that tiny, almost negligible surplus, 1 part in a billion, is what survived. That surviving 1/1000,000th is the entire physical universe, every galaxy, every planet, every atom in your body. You are not the main event of this story. You are a rounding error that happened to survive it. By the time the universe was 10 seconds old, it had cooled enough for the surviving protons and neutrons to start doing something new, sticking together through the strong nuclear force to form the very first atomic nuclei. This process is called Big Bang nucleosynthesis, and it's the reason this episode is named what it is. For the next several minutes, and this is genuinely one of the strangest facts in all of cosmology, the entire universe behaved like the inside of a star. It was hot and dense enough for nuclear fusion to happen everywhere, all at once. Protons fused with neutrons to form deuterium. Deuterium fused further into helium. A trace amount, one atom in about 10 billion, fused all the way into lithium. And then, almost as quickly as it started, it stopped. The universe was expanding fast enough that within about 20 minutes, the temperature and density dropped below the threshold fusion needs to happen. The furnace shut off. What was left behind, once the numbers settled, was a universe made of roughly 75% hydrogen and 25% helium by mass, with only the faintest trace of lithium, and virtually nothing heavier. No carbon, no oxygen, no iron. Every heavier element that exists today, the calcium in your bones, the iron in your blood, the oxygen you're breathing right now, had to wait for stars to be born first, and would take billions of years to arrive. This one number, that specific 75-25 ratio, is one of the strongest pieces of evidence we have for the Big Bang model. When astronomers point telescopes at the oldest, most pristine gas clouds in the universe, untouched by any star, that is exactly the ratio they find. The math, done on paper decades before we had the telescopes to check it, turned out to be correct. It's worth sitting with what that actually means. Iron, calcium, oxygen, the elements your body runs on every single day, didn't exist yet and wouldn't for a very long time. The 3-minute-old universe could build hydrogen and helium and almost nothing else. Everything more complex than that had to wait for stars to be born, live, die, and explode, seeding space with the raw material for chemistry, planets, and eventually, biology. So here we are, 3 minutes in. The clock we started at the beginning of this video has run out. In these 3 minutes, the universe built the raw ingredients for everything that would ever exist. Hydrogen and helium nuclei drifting through space, vastly outnumbering the electrons around them. But here's the twist most people don't expect. Even though we've just described the birth of matter itself, the universe at the 3-minute mark is completely, utterly dark. Not because there's no light. There's an almost unimaginable amount of light, energy left over from everything we just described. But that light can't go anywhere. It's trapped, scattering endlessly off of loose, free electrons, unable to travel in a straight line for more than a fraction of a millimeter before it's bounced again. The universe at this point is less like a night sky and more like the inside of a thick fog bank, lit from within but impossible to see through. That fog doesn't clear for another 380,000 years. That's how long it takes for the universe to cool and thin out enough for electrons to finally settle into orbit around those hydrogen and helium nuclei, forming the first true atoms, and for light to finally break free and travel in a straight line for the first time in the universe's history. That moment, the moment light was finally set free, is the reason this channel exists. It's the reason it's called what it is. That's the next case we open. Every atom of hydrogen and helium in your body was forged in the 3 minutes you just watched. It took another 13.8 billion years, several generations of dying stars, and an enormous amount of cosmic luck for those atoms to end up arranged into something that could sit here and watch a video about where it came from. Here's a question worth sitting with. If that 1 in a billion imbalance had gone the other way, if matter had lost instead of survived, there would be no story to tell and no one left to tell it. Let me know in the comments which part of these 3 minutes surprised you the most. If you want to be here for the moment the universe finally lit up, subscribe, and I'll see you in the next episode.